Hello, I am Davi Himan from Inibits Consulting in Johannesburg, South Africa. My colleague Andre is on my right-hand side. Today we have an interesting problem. I'm currently on a project and I have to buy a few servers for a small to medium enterprise, and I'm evaluating the options of buying Server 2008, Microsoft Server 2008 with Hyper-V as an option to scale the environment. Andre, the other day I met with a client, and it's about a 30 to 40 user company, and we are seriously looking at using a Windows Server 2008 with Hyper-V. And now I have to go through the process of buying a capacity planning the actual server itself. I've heard some interesting things on the networking side. What should I consider in the networking department for Hyper-V specifically?
From a networking point of view, you obviously have to make sure that the server can handle the throughput that you're going to be putting in. But if you go for something like Gigabit Ethernet and make sure that the rest of the network is Gigabit Ethernet, you shouldn't have any problems in that regard. What you should also be looking at is having more than one adapter in the server, because the general recommendation for server 2008 with Hyper-V is that you have one adapter that can be used by the virtual machines.
Why specific? What is the requirement? Why specifically this one little network adapter by its side? Why would you need that one? Do you think it's because I've heard, say for instance, the synthetic layer in Hyper-V, maybe it utilizes all the network adapters, so at a stage if something fails, maybe that synthetic layer, that you lose connectivity?
Well, that would be the reason to have a second management adapter, because the way that Hyper-V works is that your adapter basically starts being managed by Hyper-V. So if you have a Hyper-V failure, it can cause your entire networking access to that adapter to fail.
Okay, so I say for instance, I have my one adapter for management and I have three other adapters for the virtual machines. Is it very easy to assign these adapters to a virtual machine?
Yeah, what you do is you create virtual network switches that can be used to be shared to virtual machines. So you can have multiple virtual machines sharing a single switch, or you can assign different switches to different adapters. So if you have a very high throughput for one virtual machine, you can give it its own adapter.
Okay, so one virtual machine can have one adapter, but two virtual machines can share adapter as well?
Correct.
Okay, that's interesting. So if in the case if I then buy four adapters or four ports, I can host one for the Hyper-V machine and the other three I can share. And then if we move on, say for instance, to the hard drive department, is it better to buy internal, say for instance, or iSCSI? What am I looking at?
Essentially, you just have to make sure, first of all, that you have the space, because your virtual machines are going to take up quite a bit of space for creating the virtual hard disk files. There's also the option now in Hyper-V that you can do pass-through disk access, where you can actually give an entire physical disk to a virtual machine, which theoretically is a little bit faster in the performance department. It also gives you the benefit from a manageability point of view that you can then, when the virtual machine is shut down, potentially access that disk directly.
But if I can bring it back maybe to space requirements, I have to buy maybe 1 terabyte, 80 gigabyte. What am I looking at storage?
It's going to take as much as the virtual machines that you are going to be creating. So if you in the past would have installed Windows and applications and data into a machine, and that would have taken up 20 gigabytes, you're now going to need 20 gigabytes of space on the host machine for that virtual machine.
Yeah. I'm planning to use Exchange 2007 in that environment. So it's better to maybe buy my storage into one big bulk and put everything on there or should I split it up into different areas?
All the usual same requirements or recommendations would still apply in your storage. So for optimal performance, you're probably still going to want to create a storage environment where you would be splitting out things like databases from log files from operating system.
Okay.
Now, if you're going to start creating a lot of storage for virtual machines, you're probably very soon going to run out of the capacity of what you can put inside of the box. You can obviously buy a number of large, cheap drives, SATA for instance, but you ultimately might run into the situation where the I/O traffic that will be generated by all of the different virtual machines will just exceed the capabilities of those internal disks. So you might want to go for some sort of external storage device, and that's where something like iSCSI becomes a good option.
Fine, so let's go for external. That also gives me the option, say for instance, I can create a failover between two virtual servers on two different hosts. Isn't that true?
Absolutely, because one of the problems that you face is if you have one host server that's running all of your virtual machines, if that one host server were to break due to a hardware failure, let's say, that means that all of those virtual machines immediately cease functioning. So you need some form of fault tolerance as well. The best solution is that you get yourself two servers and you set up Windows Server Enterprise Edition. You set up failover clustering between the two hosts, and you can then actually make the virtual machines highly available so that they can fail over from one host to the next.
Right.
But your requirement for that is, just like all Windows clustering, you need somewhere for the data that you are clustering. And in this case, that would be the iSCSI device, where you would then assign a LUN to each one of those virtual machines, and that's what would then be failover.
To summarize that then I would buy, say for instance, a half a terabyte of storage, divide part of that for the mailbox, or I want pass-through access straight for the mailbox for the high activity, and I will assign it to the one host, and maybe create two VHDs for the CAS and the hub roles, put that on a different LUNs, put on server A, so if server A fails, I have the option of failing it across to server B.
Absolutely.
And then the data just transfers to the other one, and the system continues from a redundancy perspective. Now, my question is, now we've sorted out the network and we've looked at the hard drive, and now memory requirements, what are we looking at memory here?
Well, it's a fairly simple calculation. What you're going to end up doing is you will first of all have to calculate what will be the memory requirements for each virtual machine. And that'll be exactly the same as if you were designing physical machines. So if you calculated in the past that, let's say, a SQL server would have needed 2 gigabytes of RAM, your Exchange server was going to need 4 gigabytes, your file and print server was going to require 1 gigabyte, then essentially you need to take the sum total of those memory and add it together, and that would be the amount of memory you would need inside of the host, plus then the memory that would be required by the host computer.
Hyper-V doesn't have the option, say for instance, if I sum everything together and we get to 20 gigabyte, and if I only have the budget to buy 16 gigabytes, does it make sense to buy 16 and run a requirement of 20 gigabyte?
Unfortunately, that is not a capability that Hyper-V has. A couple of your other virtualization solutions on the market support what they call memory overcommit, which allow you to assign more memory to your virtual machines than what you physically have. How they manage that is by essentially paging out the difference between the physical memory and the memory that they've allocated, which, just like all paging, immediately gives you a performance disadvantage. And you'll find that the other vendors, if you go to their websites, will actually tell you that memory overcommit is not something they recommend unless you have a emergency situation where you suddenly need more memory than you've got. So Microsoft chose the route to not support memory overcommit. So in result, you will have to calculate out how much memory you need, and you can only give as much memory as what you physically got.
So from a perspective, if I calculate myself a 32 gig requirement, then I must make sure my motherboard and the system can handle 32 gigabytes. Is there an upper limit to in Hyper-V to memory?
Up to 64 gigabytes.
That is enough to run a few servers on each other.
You'll be able to run a lot of servers inside of there. You can
move on to the CPU environment. How many processors do you require to run, say, for instance?
Well, there Hyper-V supports up to 16 cores, okay, which could, for instance, be 4 4-core processors.
4 4-core processors. So if I now buy 4, or if I go more than the 16 cores, then I have to somehow lock it down. Isn't that true? So
that is the recommendation. Yes.
Yeah, something. And then for the small company, it's quite feasible to run a dual processor, maybe 2 quad cores.
Absolutely, yes. You then just have to make sure that, again, you don't overcommit on the processor allocation to the virtual machines. You can allocate up to 4 logical processors per virtual machine. Again, the recommendation is that you rather sum up the virtual processors that you're going to be allocating and try not to exceed the amount of physical processors inside of your machine, or the physical cores inside of the host computer.
Right, so now we've seen, if you want to, in a small to medium business and you want to buy yourself a server to run Hyper-V, you're looking at a network card, at least for the Hyper-V, plus 3 or more network cards for the virtual machines. Memory, calculate your memory requirements carefully, and enough processors, because you can share your processors. Thanks.